Hello friends, in this video we're going to discuss about orthogonality of Bessel function, and this is the orthogonal property of Bessel function, and we're going to prove this property. So here you see this integral on this left hand side is equal to 0 if alpha is not equal to beta, and where alpha and beta are the roots of Zn x is equal to 0. Okay, and if alpha is equal to beta, then this integral is equal to either this one or this one. Okay, so we are going to prove that. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID, OJHALAKHYAJIT123. This is my Insta ID. You can follow me on Insta. So now let's start. So first, let me write the Bessel's function, Bessel's orthogonal property. Okay, orthogonal property of Bessel's function. So here you see this integral from 0 to 1, integration from 0 to 1 of x Jn of alpha x, then Jn of beta x dx. That's gonna be equal to 0 if alpha is not equal to beta. Okay, and it's gonna be either half of Jn of alpha, Jn dash of alpha is whole square. Okay, or it may be equal to half Jn plus 1 alpha. Okay, if alpha is equal to beta, and where alpha and beta are the roots of this equation, right? So that Jn of alpha that's equal to Jn of beta is equal to 0, because these two are alpha and beta are the roots of Jn of x is equal to 0. That's why, so if you replace this x by alpha or beta, then you must get 0, right? Hope you have understood this. So now let us prove this. Before we prove this, let me tell you one more thing. So we know that Bessel's equation is given by this x square second order derivative of y with respect to x plus x into again dy by dx plus x square minus n square y is equal to 0. This is Bessel's equation. Now you see, and solution of this equation is nothing but Jn of x. Now suppose before x square, if we have any number, suppose we have alpha square, then its solution will be Jn of alpha x. Okay, and if we have beta square here, suppose let me write here beta square x square, suppose we have beta square x square, then its solution will be Jn beta x. Okay, so hope you have understood this. So now let me prove this. Okay, so let me write here proof. Okay. Now you see, we know that y is equal to Jn of alpha x, and let me write z. Okay, so we are not going to use the same variable y for two different cases. Okay, so Jn beta x, okay, respectively are the solutions of equation of the equations, sorry, let me cut it, of the equations given below. Let me write here written below. Okay, so what are the equations? So let me write the first equation. So whose solution is this? That equation will be x square, second order derivative of y, because we are writing here y is equal to jn of this, second order derivative of y with respect to x, plus x into first order derivative of y with respect to x, plus now we have to write alpha square x square, alpha square x square minus n square into y is equal to 0, and the equation whose solution is this, that will be, and that equation will be, let me write here, just give me a second. Okay, as I am writing here z, so this equation will be written in terms of z, x square, second order derivative of z, okay, second order derivative of z with respect to x, plus x first order derivative of z with respect to x, then plus, so here we have beta x, so beta square x square minus n square into z is equal to 0. Okay, so these two are the solutions of these two equations respectively, right? Hope you have understood this. Let me take this as equation number 1, and let me take this as equation number 2. Now let me copy these two equations and let me go to a new slide. Okay, let me take a new slide as we have not enough space here. So these are the two equations. Okay, and let me multiply z by x and equation number 1. Okay, let me multiply both sides of equation number 1 by z by x. Then what we're gonna have, so let me copy this equation number 1. So here is the equation number 1, you see. So if we multiply z by x with each and every term, then what we're gonna have, let me write here properly. Okay, so here you see. Okay, let me show you something. Okay, now let's multiply z by x here, and here also z by x, and here also z by x, and 0 into anything is again 0. Okay, so here we're gonna get 0 into z by x remains 0, right? So here x gone, here x cancels x square. Okay, so hope you have understood this. Then what we're gonna have, so this equation will be of this form, z into x, right? Z into x, second order derivative of y with respect to x. Then here we're gonna have z only in the second term. Okay, z into this, right? Now what we're going to do, we're going to multiply minus y by x with equation number 2. Okay, now let us multiply minus y by x into equation number 2. Okay, so here you see, if we, let me write the equation number 2 here. So here is the equation number 2, right? So now if we multiply this minus y by x, then what we're gonna have, let me show you here. So if we multiply minus y by x here, then x cancels x square, then it's gonna give you minus yx, right? And if you multiply here minus y by x, right, then x cancel, so we're gonna get here minus y, so this plus will be minus y into dz by dx, right? Dz by dx, that's what we're gonna have. Then here this plus gonna be minus y by x, so let me write here y by x into this is what we're gonna have, right? So hope you have understood this. Now you see, let me write this is equation number 3, this is suppose equation number 3, and this is equation number 4. Okay, now if we add this to equation number 3 and 4, adding equation number 3 and equation number 4, what we're gonna have, now here you see, from these two terms we can take x common, right? We can take x common. Okay, then if you take x common, then what we're gonna have x, and within bracket we're gonna have z into second order derivative of y with respect to x. That's what we're gonna have. Then minus, as there is minus y, okay, minus and minus y, then second order derivative of z with respect to x. That's what we're gonna have. And from the next term here, you see, from these two, so nothing is common here, so we can write this way: plus z dy by dx, okay, dy by dx, just give me a second, let me write it properly, z dy by dx, then minus y dz by dx, okay, minus y dz by dx, what we have, that's what we're gonna have. Now if we add these two terms, just give me a second, let me copy this. If you see on the right hand side, 0 plus 0, that's remains 0, then but here you see, let me show you what we're gonna have if we add these third terms, these two terms, okay. So let me write these two here, just give let me show you what we're gonna have, okay. So from these two terms here, you can see if we add these two, then what we're gonna have, let me simplify this first. So here you see, first multiply this one with this, then what we're gonna have, so z x, because x cancels x squared, so we're gonna have x, then alpha squared minus, sorry, one more thing, there must be a y, this y, okay, then minus z n squared by x into y, so we can write this way, z y into n squared minus, so similarly if we multiply this one with this, y, x cancels x squared to give x, so y x, then into z, so we have z as well, beta square, then this minus gonna be plus y n square into z, so y z n square, we can write y z n square by x. So here you see these two terms cancel, y z n square by x, one is positive, another is negative, so that's why these two terms cancel. And from these two terms we can take x y z common, right? From these two terms we can take x y z common, and after taking x y z common, let me write here, after taking x y z common, we're gonna have alpha square minus beta square, right? We're gonna have beta square, so that's why we can write here minus x y z, or you can write minus alpha square, sorry, not minus, here it's supposed to be plus, okay, minus beta square, then x y z, that's what we're gonna have, right? So hope you have understood this. Now let me clean these things, okay. That is what we have got. Now you see, first let us take case 1, as we have two cases here, one is alpha is not equal to beta, and second case is alpha is equal to beta. So now let me take the case 1, okay, case 1 where alpha is not equal to beta, okay. So in that case, what we can do here, now you see this part, okay. So observe carefully here, you see this is nothing but, you see, derivative of ddx of x into z dy by dz, sorry, dx minus y dz by dx. Why? Let me tell you. If you consider this is as u, and if you consider this one as v, then what you gonna have? If you apply this rule, ddx of u into v, where u and v are the functions of x, in that case du by dx into v plus u dv by dx. That's what we get, right? Or you can write this way also if you want to write. Then you first function derivative of second function and second function derivative of first function, right? This is derivative of first function into second function. You can write this way. So now you see, if you consider this one as first function and if you differentiate this with respect to x, then you're gonna get this term, right? Hope you have understood this. So if you differentiate this again, you're gonna get this second order derivative of y with respect to x, and if you differentiate this with respect to x again, then you're gonna get this, right? Hope you have understood this. So what we're gonna have, we're gonna have this x derivative of ddx of z into dy by dx plus, sorry, not plus, minus y dz by dx, okay? Then plus derivative of the first function ddx of x, so which is nothing but 1 into this part, okay, into this part. That means, just give me a second. So what we're gonna have, plus ddx of x into this z dy by dx minus y dz by dx. That's what we're gonna have. So that's why we can write this part this way, right? So now let me clean this, let me write it properly. Okay, just give me a second. Okay. So now what we can do, we can write that ddx of x into this, just give me a second, this, right, is equal, sorry, plus, so instead of this part I have written this, and plus alpha square minus beta square into x y z is equal to 0. So that's what we have got. So let me take this as equation number 5. Okay, now let me copy this and let me go to a new slide. Okay, so this is the equation number 5. Now let me integrate equation number 5 with respect to x from 0 to 1. Okay, so what we have here, so if we integrate this from 0 to 1, right, 0 to 1, so on this side we have 0, so that's gonna remain 0, right? So then what we're gonna have, this differential coefficient will be removed if we integrate, as simple as that. One more thing, so this can be written this way. So instead of dy by dx, we can write this way here, d, and here dx, okay, dx as well. So dx into 0, that's going to be again 0, right? Hope you have understood this. Okay, so if you integrate this, then what we're going to have, integrating equation number 5 from 0 to 1, from 0 to 1, what we're going to have, if we integrate this, then we're going to have this differential coefficient will be removed, right? So this is going to be equal to this 0 to 1. We are integrating it 0 to 1. Then, so here this part is constant part, so we can write this integral here, you see, give me a second. So we can write this one here. Okay, so hope you have understood this. So this implies that, let me write this one on the left hand side. This implies this is equal to minus this, right? Hope you have understood this. If you make it positive, then you have to multiply minus here, okay? Then this minus of alpha square plus minus beta square, that's going to be beta square minus alpha square, right? That's going to be beta square minus alpha square, right? So hope you have understood this. So let me write it properly. This is alpha square. Okay, this is that's what we have got, right? So now you see, now we know that that we have taken y is equal to Zn of alpha plus alpha x, and the solution of the next equation number 2 was Zn of beta x, right? So these were the two solutions of these two equations. Let me go show you the first slide. So here you see, as we have taken these two are the solutions of this equation number 1 and equation number 2. Let me write these two solutions here. Here you see, just give me a second. Y is equal to Zn of alpha x, and Z is equal to Zn of beta x, right? So that's why dy by dx, if we differentiate this, then what we're gonna have, Zn this of alpha x, then again this is function of function, you need to differentiate this which is within the bracket. So if you differentiate alpha x, then you're gonna have alpha, so that's why you must write this as alpha Zn this of alpha x. And similarly dz by dx, that's also gonna be equal to beta Zn beta x, right? So hope you have understood this. Now okay, let me replace these two and these two as well by these results. Okay, so now you see, so what we can do, so using these results, just pause the video and note it. Let me copy this part and let me go to a new slide. Okay, let me copy these things and let me take a new slide. So here you see, these are the last steps we have got. This is equation number suppose 6. Now let me use these results, using these results in equation number 6. Okay, using this in equation number 6, then what we're gonna have. Okay, you don't need to repeat these things, as I have already written here, as I have already written in this slide. You don't need to repeat these things again. This is equation number 6. Okay, so now using these results here, what we're gonna do, here this y will be replaced by this, and this z will be replaced by this. Okay, similarly here also these two y and z will be replaced by these two results, right? And similarly this dy by dz dy by dx and dz by dx will be replaced by these two results. Okay, so then what we're gonna have, the left hand side becomes beta square minus alpha square integration from 0 to 1 x, then Zn, instead of y we're gonna write Zn of alpha x, then we have z here, instead of z we're gonna write Zn of beta x, okay, dx, right? On the right hand side, this x remains x remains as x, then z will be nothing but this Zn, then dy by Zn of beta x, then dy by dx is this, that is alpha Zn dash of alpha x, right? Then minus we have y here, so y will be replaced by again this value, that is Zn of alpha x, into we have dz by dx, so that gonna be replaced by this value, that is beta Zn of beta x. That's what we're gonna have. So we are integrating it from 0 to 1, right? That's what we have done. So now you see, let me copy this and let me take a new slide again. So here is the last step we have got. Now let's put the upper and lower limit. On putting 0 we will get all the terms 0, so let's put the first upper limit. Okay, so the right hand side will be of this form. On putting 1 we're gonna have Jn beta, x is replaced by 1 now, then alpha Jn dash of alpha minus Jn Jn of alpha, because this x those are replaced by 1 now. Okay, hope you have understood this, into beta Jn of, so here it's supposed to be Jn dash, okay, beta x. So I made a mistake here also, here it's supposed to be Jn dash, right? So beta Jn dash of beta x, that's what we have got. And on putting 0, this terms become 0, so this is the result we have got using the upper and lower limits, right? So now you see that as already mentioned earlier, that as already mentioned in the orthogonal property, that alpha and beta, since alpha and beta are the roots of Jn of x is equal to 0, so Jn of alpha must be equal to Jn of beta must be equal to, both must be equal to 0. So here we're gonna get here you see this Jn beta gonna be equal to 0 and Jn alpha gonna be equal to 0. So this whole part gonna be equal to 0, because 0 into anything is 0. So that's why the left hand side, let me take this left hand side is this is the left hand side, and that's going to be equal to 0 minus 0, that means 0, and which implies that integration from, let me write it properly, integration from 0 to 1 x Jn of alpha x Jn of beta x dx is equal to 0. Okay, when alpha is not equal to beta. So this first condition is already proved, right? This first condition is already proved. If you see the condition, if you see the property here, you see, so when alpha is not equal to beta, then this result is equal to 0, right? Now let us prove this part. Okay, so now let me go to the last slide here, you see. So this thing is proved now, right? Okay, now you see, now comes to second condition, that is alpha is not equal to beta. So for that, let me do one thing, let me copy this step and let me go to the next slide. Okay, so one more thing what I can do, just to give me a second. So here you see, this can be written this way, just so now you see, okay, one more thing here, this x should not be there, because I have already put the upper and lower limit, so it's supposed to be beta only, so beta of this. So let me take this as equation number 1, suppose, equation number 7, this is suppose equation number 7, and let me copy this and let me go to the next slide for the second condition. Okay, that is alpha is equal to beta. And one more thing, you can divide both sides by beta square minus alpha square, this side divided this side. Okay, then this one will be cancelled. So if you do so, then this equation number 7 will be of this form. Let me write on the next slide. So here we have got this. So now you see for case 2 beta is equal to alpha or alpha is equal to beta. Let us consider that B is beta, B a neighboring value of alpha and which tends to alpha. That means beta tends to alpha. Okay, then what we can do, let me here you see, and also we know that, and also Jn alpha is equal to 0, Jn alpha is equal to 0, so we can make it 0. So then what we're gonna have, let us take limit on both sides, limit beta tends to alpha. Then let me write the left hand side. So this is beta tends to alpha, not infinity. Okay, this is alpha, right? And on the other side, limit again beta tends to alpha. As Jn alpha, this becomes 0, so we're going to write beta tending towards alpha and Jn alpha is equal to 0. Okay, so we have considered that way, and that's why we can write that alpha Jn beta Jn dash of alpha minus 0. So that means we have got this. Okay, beta square minus alpha square. Now let us apply the L'Hospital rule. Okay, so according to that rule, if you see limit x tends to a, f of x by g of x, and if f of a and g of a is equal to suppose 0, okay, for x is equal to a, if these two functions are 0, then we can apply the or infinity, then this will be of this from 0 by 0 form or infinity by infinity form. In both cases, if this is 0 by 0 form or infinity by infinity form, then in both cases we can apply this rule. So that's going to be equal to, you know, limit x tends to a, f dash of x by f g dash of x. Okay, this is the L'Hospital rule. So let me apply that here. You see, here one more thing. As the limit is of the form 0 by 0, so let us apply L'Hospital rule. Okay, then what we're gonna have, just pause the video and note it. Okay, so now let me scroll the page. Okay, so hope you have noted what I have written earlier. Okay, so now what we're going to do here, first let me write the left hand side. Here you see, so as beta tends to alpha, we can replace this beta by alpha. So that's why this left hand side gonna be equal to 0 to 1 integration x Jn square alpha x dx, right? That's what we're gonna have, because this beta is replaced by alpha and this is also alpha, so we can write this way. And on the right hand side, if we apply the L'Hospital rule, then it will be of this form. Let me show you. Limit beta tends to alpha, limit beta tends to alpha, alpha Jn dash. So we have differentiate this with respect to beta, so this becomes Jn dash beta, then Jn dash of alpha, and if you differentiate with respect to beta, then beta square will be twice beta and alpha gonna be 0, derivative of alpha gonna be 0, right? So hope you have understood this. And here you see, let me write it properly. Okay, as beta tends to alpha, you can replace this beta by alpha. Wherever you have beta, you can replace that by alpha. Then you're gonna have alpha Jn dash of alpha, again Jn dash of alpha divided by twice alpha, then alpha gone. So we have got let me copy this right hand side. So what we have got, this is equal to half j n dash of alpha, this whole thing square of this thing, right? Hope you have understood this. Now let me copy this and let me go to the new slide. So this is what we have got. This is proved. Okay, we have got one result. Let me show you this. We have got this result. Now let me obtain this. Okay, so now let me show this is also equal to half Jn plus 1 of alpha whole square. Let me prove that one also, right? So how to prove that? So here we need to use recurrence formula that we have already got. I have already explained in earlier classes. So I have provided the link of the playlist in the description box. Please watch those videos first 3 or 2 lectures. How many lectures I have made, I forgot actually how many lectures I have made. Okay, now you see, we know this recurrence formula that x j n dash of x is equal to n j n alpha. So here I am writing in case of alpha. Okay, instead of x, let me write alpha. So j n alpha minus x jn plus 1 of alpha. So here you see, so let me make it alpha instead of x. Okay, that's what we have got. Now you see, since jn alpha is equal to 0, jn alpha equal to 0, so this term gonna be equal to 0, right? So let me write here properly. Recurrence formula, we know this. Let me write in terms of alpha. So actually earlier we have got this formula in terms of x, right? X jn dash of x is equal to n jn x minus x into jn plus 1 of x. Okay, we have got this. Now let me replace all the x by alpha. Okay, let me write this in terms of alpha. Let me write this same formula in terms of alpha. Okay, so we're gonna have this result, right? So now you see, this will be equal to 0 since jn alpha is equal to 0. So we end up getting this jn dash of alpha into jn dash of alpha minus alpha into jn plus 1 of alpha, right? So here these two cancels, so we're gonna get jn dash of alpha is equal to minus jn plus 1 alpha. That's what we're gonna have. Okay, so let me use this result here. Then what we're gonna have, therefore we're gonna have integration 0 to 1 x jn square alpha x dx is equal to half jn dash of alpha whole square. Okay, then this can be replaced by this result. Okay, so if we do so, then what we're going to have, half minus jn plus 1 alpha this whole square. As we have square here, so this minus can be here, this minus will be plus, right? So here we had minus, on squaring this minus, this will be plus. So this result will be of this form, jn plus 1 alpha. Okay, that's it. That's what we have got. This is to prove. Okay, so hope you have understood this. Okay, so see you in the next video. Thank you for watching. See you in the next video. Bye bye.